In industries, to control the speed of the motor or to control the several actuators, again in your home UPS, again in solar, in most of the power stations, wherever power is required to operate any of the machines or any of a system, we require power converter. Power converter will convert power from one form to another form. For an example, maybe AC to DC, DC to AC, like that. In future, most of the vehicle, most of the vehicle may become electric vehicle, especially electric car. See here, it requires one inverter, it requires DC to DC converter, it requires onboard charger, so wireless charger. In here you can see some DC to DC converter. So why I am saying here, there is a question whether power electronics is required for future generation. Yes, power electronics is required for a future generation, and it is more widely used in electric vehicles in future. So in future there is a big demand for a power electronics circuits. Okay, so we'll go to next slide. We have already studied this uncontrolled rectifier. What is the job of rectifier? Rectifier converts AC to DC, alternating current to direct current. For an example, some appliances, here I have shown this as a R resistance. It is a symbol of load. Instead of load, we have shown it as a resistance. Okay, assume that this load requires DC for its operation, and I want to operate this DC appliances using AC supply. The requirement is to convert AC to DC form using this circuit, using these two diode circuits. Then we will get an output like this. It is DC, and this DC we can apply to this load, so that this load will receive that power and it will start operation. What is the DC value of this supply? See, if you integrate these waveforms from 0 to 2 pi, why I am integrating from 0 to 2 pi means, whenever we want to calculate the average value of any waveforms, if it is a periodic, this is a periodic waveforms, the period of this waveform is from 0 to 2 pi. This is one complete cycle. If you integrate from here to here, what happens? All positive is cancelled by negative part. So average value you will get 0. the DC value of this power is 0. This is a pure alternating current. What is the if you want to calculate the DC value or average value of this voltage, we should first of all we need to find out the one periodic waveforms. This is a periodic waveforms. This pattern will repeat again and again. So if you take average of this 0 to pi, if you integrate these waveforms, what is a waveform's mathematical expression? Vm sin omega t. If you integrate from 0 to pi, Vm sin omega t d omega t, and if you divide by pi, you will get average value. That average is not 0. See, easily you can understand that there is no negative part here. If you add all this together, or if you integrate these waveforms, you should get positive value, and that is non-zero value. Positive value and non-zero value. That's the reason this is DC. So in the positive half cycle, what happens? D1 conducts. So power comes through resistor in this way. In a negative half cycle, D2 conducts. Power current flows in this way. So if you consider the direction of the current in load side, in the first half cycle, D1 conducts. This is a current direction. In the second half cycle, D2 conducts. This is a current direction. So both half cycle, the current direction is not changed in the load side. Okay, so this is simple AC to DC converter. So assume that right now this is giving you 10 volts DC. This, if you take average of this, it is giving you 10 volts DC. And assume that this is a small DC bulb, and I want to apply 5 volts now to reduce its brightness. Is there any mechanism to change the output voltage from 10 to 5? No. Only one way is we should connect one extra resistance here. What happens? So there is an I squared R. So lot of power is wasted across that resistance. Otherwise, this voltage we cannot change. In all cases, only this voltage is applied. Even if you want to reduce this voltage, average voltage, there is no option, thinking that the input voltage is constant in terms of magnitude and in terms of frequency, everything. So we need to think about controlled rectifier. That's the reason this is called as uncontrolled rectifier, because there is no control over the output voltage. Means average output voltage is always depends on my input prime voltage in the primary, secondary. So it not even if you want to control, we cannot control it. So we'll check what is uncontrolled rectifier. See here this is half wave rectifier. Okay, instead of diode we are using a component, its name is SCR, silicon controlled rectifier. Silicon controlled rectifier. So you can call this as thyristor also. Here there is an input, yes, as usual. This is a source voltage. How this is a source voltage? Mathematical expression for this is Vm sin omega t. So when sin omega t, this is when it is 0, omega t is you will have 0. When it is 90, Vm again 180, 0, 270 minus Vm, this. If this is my input, if you use a diode here, what happens? This complete half cycle comes here, and in the second case also complete half cycle comes here, correct? But for all the circuit, whatever may be the load resistance, forget any of load resistance. In all the cases, if you use the diodes, what happens? In always full half cycle comes. But here we have not used diode, we have used SCR. This is having one property. Yes, when diode will turn on, when the anode to cathode voltage is more than 0.7 volts, diode will turn on. Here, correct? These diodes will turn on when anode to cathode is more than 0.7. If applied voltage is more than the barrier potential, diode will turn on. But here we will talk more about this device later. Right now you remember why I am saying this is a controlled rectifier. This SCR will turn on only if you apply a gate pulse to gate, or if you apply a gate voltage, or if you inject a gate current. Right now you remember, if you apply a gate pulse to this gate, means this SCR consists 3 terminal, anode, cathode and gate. As usual, anode should be made more just okay, you don't worry, like a lot of things is there. Right now assume that it is connected like this. In positive half cycle, positive half cycle, if you apply a voltage to gate, or if you apply a current to a gate, if you inject a current to the gate, then only this SCR will turn on. See, I will give you an analogy of Mosfet. You can use, instead of, if you use, assume that Mosfet is having 3 terminals. One is drain, source and gate. When Mosfet will turn on, if you apply a gate pulse, then only current will flow through drain to source. In BJT, if base emitter is forward biased, means in the presence of base current, only current is passed from collector to emitter. Listen here, in all these cases, I am using these devices as a switch. Means here we require some switch. That switch should in off state, means it should disconnect these 2 wires, this wire from here during this period, and it should connect these 2 wires during these periods. So what I am doing, I am applying a gate pulse somewhere here, somewhere here, somewhere here means at alpha. I will tell you a lot of things are here. So then until this alpha, for an example, this may be a 60 degree, we are not applying gate current. So SCR remains in off states. So SCR acting like an open switch. So no connection between these two terminals. So load is isolated from source. Load will not receive any current from source, or load is not receiving any power from source. We are applying, for an example, if you consider this a 60 degree, we are applying a voltage to this SCR at an angle alpha or at 60 degree. Once we apply a gate voltage, or if you inject a gate current, assume right now SCR will turn on. From 60 degree to 180 degree, SCR remains in on. So it is acting like a closed switch. Means this and this is connected by a switch. So current flows through this, current flows to load from source. What is the load voltage? Load voltage is same as source voltage because it is connected by a short circuit. So what happens here? Current flows from alpha to pi. For an example, if you integrate these waveforms, you will get some value, correct? Assume that you don't require this average value, you require still less. What is the requirement? I should not apply a gate voltage to the gate. Assume that I require still lesser voltage. You apply a gate voltage somewhere at 90 degree. So what happens? Only half part will be delivered to load. In the sense, the SCR will conduct from 90 degree to 180 degree. 90 degree to 180 degree. So 90 degree to 180 degree. So only less voltage is delivered. If you want to deliver a still less voltage, you apply gate voltage after 120 degree or at 120 degree. So from 120 to pi, load is given, source voltage is connected to load. So source will deliver a power to load only from 120 to 180. So still less small different waveforms comes from like this. So if you take average of that, still lesser voltage we can apply. Summary of this is, if you compare uncontrolled rectifier and controlled rectifier, so the load voltage we can control in controlled rectifier. There is a separate chapter about this. We'll talk more about this. Right now you understand SCR is a power electronic circuit consist controlled rectifier also. Here, see here, DC to DC converter. The input is DC. The output is also DC, because see here there is no negative part. But if it is a 10 volts, this is output is from 0 to some time t on till this. Assume that it is 5 milliseconds. 0 to 5 millisecond it is 10. 5 millisecond to 10 millisecond 0. 10 to 15 10. Instantaneous value is 10. 15 to 20 millisecond instantaneous value is 0. If you consider that T on is 10 millisecond, T off is 10 millisecond. If you take average of this voltage, what happens? If this is 10, if this the value is 10, average is how much? Is 5 only. Average means what? because here there is a 10, for the same duration 0, 10, again if you integrate 0, if you integrate from 0 to 10 millisecond, what is the voltage? 10. From 10 millisecond to 20 millisecond, 0. So if somebody is asking you what is an average voltage you are delivered to load, it is only 5 volts. So 10 volts we can convert to 5 volts in this way. Anyhow, this is DC to DC converter. Anyhow, there is a separate chapter for this, we will study that. So only what is required here? Switch. You can use SCR as a switch, you can use Mosfet as a switch, power Mosfet as a switch, power BJT you can use as a switch. There is one more device called as an IGBT, insulated gate power supply. So power transistor, insulated gate power transistor. So that also you can use. Several power devices are there. Anyhow, we will study all those later. First, we require a switch. What is a switch? It should close the connection sometimes it should open the connection. So if you close the connections here, what happens here? This source is connected to load. So what is the load voltage? If you measure from here to here, what is the load voltage? Load voltage is same as Vs. That's the reason VO is Vs until you open this, means from beginning. So now we have already closed, assuming that we have already closed this, so that's the reason 0 to Vs. If you open the switch for next duration after some times, so you will get 0, you will get 0 here because it is open. This load is not at all connected to source. So what is the load voltage? Load voltage is 0. So there is you may ask, so what is a time, what is an usual time duration? Maybe it is 1 millisecond we will open, we will close this switch, and for next 1 millisecond we will open this switch. So usually that's the reason 1 millisecond means how fast we close and open the switch in 1 kilohertz, means that we call as switching frequency. Anyhow, I will talk to later that. So in this way we can convert DC to DC. Right now you just think this is a one DC, this is another DC, and from one DC to another DC we can convert. For an example 10 volts we can convert to 5 volts to in this way.